God bless my internet, hopefully. We'll see. If TikTok wants to load today, there we go. That's that. Great. Yeah, we got partner status on YouTube. Crazy work goal. Thanks, Justivibe. Yeah. Well, I figured we need to spread the knowledge everywhere. It's Sunday, fun day. We're going to do some physics, it looks like. Clickbait's already got another physics question probably coming up. Let me make sure I got all our chats integrating. 1 second. Takes me like 2 seconds. I got to activate that. We're going to activate this, and then we're going to activate this. Sunday fun day indeed, dude. Hell yeah. There we go. Show me that fourth one. You can't hear me at all? Okay. Discord is honestly kind of weird. With its stages. Like, it will just cut my audio for some reason. It's a bug for sure. Okay, 1 sec. Let me join this again. Okay. Can you all hear me now? Yeah, cool. All right, then let me share it. Yeah, there we go. Okay, cool. Well, it says it's running. All right. And then I'll figure out this working later. It should be on. Yeah. Okay, Zion, first question. Did you want to come up on the stage, Zion? Do you want to get in the voice chat? Do you want to talk? You can chill in the chat if you just want to. I don't care. Sometimes it's easier if there's like back and forth conversations. Let me know. You can't. No, you're totally okay. Don't worry about that. Yeah, don't worry about that. All right, we're stable there. We're stable there. I like it. Okay, so it says derive the corresponding D versus T and A versus. So this is like position graphs, acceleration graphs. Interesting. They're giving you just the velocity graph. I haven't seen this before. This is kind of fun. Okay. So if you want to go from a velocity graph to an acceleration graph, the key thing here to remember is that acceleration is equal to the derivative of velocity. What level of physics are you in? Are you in like AP Physics? AP Physics 1? Here, let me see if our YouTube's working. YouTube test. Good, YouTube does work. You're in grade 11. Okay, so I don't know if you've maybe have you seen this notation for it, or is it this? Is it delta V over delta T? It's delta. Okay, that's cool. That's fine. Yeah. This is the derivative way of doing it. But we can use delta as well. That's totally cool. Greetings. Yes, there we go. Okay, now my Instagram chat's working. Okay, sick. Instagram viewers doesn't work, but whatever. We'll take it. Okay, so what this means is this is the slope of a velocity versus time graph. Okay. The way I see this, because this is like delta y over delta x. So you see how this is like the y-axis, this is the x-axis. So acceleration is delta y over delta x. That's just the slope of a velocity versus time graph. Yo, what's up, Initial? Dude, I haven't seen you forever, dude. Yeah. So many friends in physics. Yeah. Oh, the Instagram's lagging. Oh, my bad. It should be running. Oh, it's still in the intro. Okay, well, it'll catch up eventually. Yeah, we're trying streaming on Instagram today, but I don't know. Maybe it's on your end. Try refreshing the page. You did? Okay, whatever. All right, I'm just gonna leave it and see what happens. Okay. So what's the slope? So I like to always like look at what I say are like key time points. Okay. So key time points are where things are changing. So for instance, I see something changing here, right? Looks like something, like there's definitely something weird happening. So that's gonna be like one key time point I'm gonna look at. The other one I'm gonna look at is like right here. And then I'm gonna probably look at something here. And then probably here. And then probably here. It's just like identifying where we think the behavior is changing, all right? Now, since an acceleration graph is the slope of velocity, we're going to look at what's happening to the slope from here to here, our first time window. The slope here is a flat line, right? And so the slope of a flat line is just 0. So this we can just draw as having a value of 0 here, okay? Because this is the slope of this. There's technically a discontinuity here because the velocity is changing very rapidly, but we don't really display that on the acceleration graph. We, again, just look at this next window and we say, hey, what's happening to the velocity here? What's the slope of it? The slope of it's also 0. So I can just draw another flat line of 0. Does that make sense so far, Zan? Yeah? Yeah? Nice. Okay, great. Yes, we've definitely done waves. All right. Empty circle in between them. Yeah, I wonder. He's only in grade 11 physics. I don't think the teacher's going to be that, like, weird. Okay, so then let's see what's happening here. This, the graph is going up, right? So that's a positive slope. We could try to approximate what that slope is, but I don't know. I don't really see any, like, numbers on anything here, right? There's not any sort of scale. So I think I can just say that it's just a sketch. Yeah, okay. So this is a positive slope. So I can just put a flat line here that is, so this is positive. This is the positive acceleration, right? So since this slope is up, we're going to put a line that's this. Also, the slope is not changing, right? Notice how the slope of this thing is constantly positive. So that means this will be a constant positive number. Actualofficehours.com. That's the best place to go. You can submit questions down there. Yep. All right. Then if we look at this one, right, this is a negative slope that's constant. So in between these two windows, we can then put a constant line that is below the x-axis, and it's negative. If you wanted to figure out exactly what this number should be, you would calculate what the slope of this is. Okay. What's up, Fembox? The solutions manual is here.
That's dope.
Okay. All right, now going from here to here, right? This is, again, a constant positive slope. So we're going to just draw, and we can be a little qualitative here. This looks steeper, right, than this. So this will have a greater slope, like a greater magnitude. So I'm going to draw another just constant positive line, but I'm going to make this one higher than this one because this looks steeper than this one. I think that's like good for being qualitative, right? How do you know it's constant? Yeah, well, I mean, look at this. Well, this is a straight line, right? Anything that's a straight line means that the slope is constant, right? The slope is not changing. The slope is, right, delta y over delta x. It's like, how much are we going up versus how much are we going to the right? And that doesn't change as you're going this way. If it was curved, so for instance, if the line was curved, then the slope would be changing because you go from, like, not steep to kind of steep to, like, really steep. This is a changing slope. Here, the slope is just always this. So it's constant, Sneaky. That's a good question, though. Yeah? Okay. All right, and then we look here. Again, flat line. So the slope's just 0, right? And there you go. So that's the acceleration graph so far. Yeah, and that would be 0. Yeah. Lurking Jeff, nice. Okay. All right, now let's get to the position graph. It's a little bit more complicated, unfortunately. How do you know whether the derivative of the line is positive or negative? So if it's going up, then it's positive, and if it was going down, then it's negative. So see here, for instance, right? This is going down as I go to the right. That's a negative slope. This region, it's going up as I go to the right. So that's a positive slope. Exactly. No. When a body is increasing in velocity uniformly, the acceleration is not 0. No. If the velocity is changing... Okay, I think Sneaky, the word is constant velocity. If velocity is constant, then yes, acceleration is 0. This is an example of constant velocity. Yeah. What's up, Kenzer? Good to see you again.
My man.
Nice. Scrimblow says, I was talking about how the integrals seemed so difficult last stream, and now my next homework involves them. I'll be needing your help. All right, I'm here, dude. We're here for the next 3 hours, 2 hours and 40 minutes, I guess. Yeah. Yes, derivative is slope. Yeah, so derivative is the calculus term for what's called instantaneous rate of change, which is the instantaneous slope. So it's a little bit different than just slope. But for now, you can think of it as just like slope. Exactly. Yes, exactly. It's the slope at a specific point. That's what the derivative is. Yeah. Yeah, another infinity stone to my multi-stream comment gauntlet. Yeah, right? Although, I don't know. Someone was telling me on Instagram that it's lagging like crazy, and it's because, like, Instagram live streaming on OBS is pretty new. So, I'm just doing it to do it. We'll just see what happens. People are joining, at least. What's your good news, Kenzer? Tell me the good news. I'm very good at Calculus 2 stuff, yes. Alright, let's get to position, though. Okay, so this is where things get a little bit weird, alright? So, velocity, which I guess we're using a blue thing here. Velocity is equal to the change in position over the change in time, okay? So, this right here is describing what the slope of this is, okay? So here's like kind of how you can say like slope, right? This shows what the slope of this is, and then this shows what the slope of this is. In 2 hours, I'm going to stream Infinite Series Practice. Oh, that's awesome. Cool. I might be tutoring someone at that time, but I'll definitely try to hop on, Fnatic. I want to see how your stream goes. You got a girlfriend, man. Oh, congrats, Kenzer. Your life's about to get more difficult. But congrats. No, it's good to have a partner in life. And actually, I think especially with Gen Z, like dating is like all-time lows. So you're a very rare person at this point in time. So good job. I definitely do private tutoring sneaky, but it's really expensive. So that's why I do this for free. All right. This is the slope of this. So we're going to try to work backwards. Technically, the correct way to do this is called integrating. But since you haven't seen derivatives, I don't think you're expected to know what integration is either. Integration is just figuring out what the area is under this. And kind of graphing it here. So, but let's not get into that because I don't want to confuse you. So let's just look at this, and we're going to work backwards, but using the same like critical time points here. All right. So here, notice how the velocity is constant and positive. That means whatever's happening here, I need the slope of it to be positive and constant. And one way to draw that would be to do just something like this, right? This is something that has a constant, right? Because the slope is not changing. Positive slope. And that's what this graph represents. Okay? All right. Then what I need is it to rapidly change here to having a negative constant slope. And I think these are like the same in magnitude. Like, let's pretend this is like +3. This is probably then also -3. So this needs to have a constant negative slope. And that's how this could be represented. Technically, I could have drawn this anywhere. Like, I could have done it here. I could have done it here. I could have done it here. Because notice how the value of this slope does not change based on what the vertical offset is. In integration, this is the +c that pops out. But, yeah, so for the calculus people, you know, that's why calculus, again, applies to this. But for you, you just need to worry about, like, what the slope is. We're not going to worry about derivatives. So, cool. All right. Now here's where things get tricky. Okay? Because now I need the slope to start changing. And here's the interesting thing. The slope has to go from having a negative value up to having a positive value. Well, actually, having a slope of 0, right? So notice, so velocity, again, this is the slope of this. And I need it to start here with a negative slope. Okay. Well, it already has a negative slope here. So I can put another just like little bit here. Let's say like this is now my negative slope. He's going to love integration in college. Yeah, you are. All right. But then that slope needs to start becoming closer and closer to 0. And so eventually here, it needs to have a slope of 0. So what we can do is at this point, I'm just going to draw like a horizontal line here because this is my slope of 0. And now we need to connect the dots going from here to here, all right? So in order for, and here, let's move it up a little bit. In order for me to go from having a negative slope to having a 0 slope, that has to look like this. Well, let me draw it a little bit better. There we go. Well, I want to... There we go. Yeah. Okay. For sure, Scrimglow. Yeah. That is... Yes, exactly. Because this is the slope of the distance. So notice how the slope started off as negative, and then it got less negative, and then it's basically 0. That's what happens here. Okay. And then it needs to go from 0 slope to again having really negative slope. Okay. So we can draw here something having a negative slope. It is supposed to lurk at a hyperbola. Exactly. Yeah. This is called concavity too, technically. So here I need to have a negative slope. Okay. And it needs to start at 0. So that's going to look something like this. Okay. The key thing here is that if this is increasing, this is technically called something that's like concave up. So notice how this is like kind of a U shape. It's like half of the U shape. Whereas this, since the slope is decreasing, that's called concave down. And so that's like, I'd say like half of like the sad face. Yeah, there's a lot of engineering applications to this. Okay, so that's a key thing. This needs to look like this, concave up. This needs to look like this, which is concave down. What's up, JC? How'd your stream go this morning? Sorry, I was not able to wake up at 7 a.m. this morning. I woke up at like 9:30. But Tuesday I might be able to catch your stream in the morning. This weekend's been pretty long. Oh, nice. Oh, you're at the football game, Justin. Oh, sick, dude. Yeah. Jeff and Penn Center and Dom popped in. Nice. Good. I'm glad. Yeah, no, we have a great community. I'm glad that they were able to come in and say hi. I'll plug you more during our stream. For sure. Locked in, dude. Yeah. Okay. Sneaky says, I'm sorry, but how can we deduce that the slope of the distance is this shape? Okay. So when you have something going from a negative slope to a positive slope, or to 0, sorry, a negative slope to 0, let's just show, right? So something with a negative slope looks like this. Something with a 0 slope has this. That had to be this, right? I mean, how do you go from going down to going flat? And you need it to change, right? The slope needs to change constantly from here, or continuously, right? It needs to do this. And this is called concave up. Exactly. Justin, I thought you were locked in on football, dude. What? Yeah, this is concave up. No, he's on Twitch, Fembox. Yeah, so again, if people want to know, yeah. So here, you can always find out when people are streaming. If you go to our website, actualofficehours.com, click on streaming schedule. JC is on there. He's here, Joseph. So he had his stream at 7 a.m. my time Pacific, because he's in the UK. But his next one will be the same time on Tuesday. And then here's his link for it. He also does math and science tutoring. He's really good at organic chemistry. Yeah. Okay. Okay, so yes, internal, what do you want to say real quick? All right. Okay. Oh yeah, we have another Joseph, not a Joseph imposter. Okay, so let's see. So then going from here to here. All right, this is interesting. So I need the slope to go from negative to 0 to then being positive, and it needs to keep changing. So this is very interesting. All right. So here it's negative at this like this is another like kind of halfway point we should have drawn. because the slope needs to be 0 here. But then the slope needs to go to being very positive once it's here. Right? So let's try to draw what that would look like, right? So going from a negative slope to 0, that's again going to be more U-shaped. So that's going to be like this. And then the slope needs to go from 0 to increasing. So that's going to look like a U-shape like this. All right. And then the slope here stays a constant positive. So it's going to keep going on whatever that trajectory is, which is like that. And there you go. I guess I could have made this like not be as dramatic. Let's have it not be as dramatic. There we go. And then it probably does it like this. Cool. How do you know whether you should draw it concave up or concave down? Okay. So if the slope is this is interesting. If the slope of the velocity graph is positive, that's called concave up. Okay. So here, slope of V is positive. That is concave up. And then if the slope of V is negative, that's concave down. Yeah. The sad face.
Surprise, motherfucker.
I'd say this is the sad face.
You done messed up, Aaron!
And then this is the happy face. What's up, Ramiro? What's going on, dude? Yeah, and then
What's
cracking, dude? We're doing a little bit of physics, dude. How's your weekend? How was Halloween?
It was alright. It was pretty cool.
What'd you go as your costume, dude? What was your costume?
Oh, me? I will. I didn't just separate anything from the person.
One sec. I can't hear you, Ramiro. Put your phone closer to your mouth. CJ says, what are some good resources for me to find optimization problems with answers for calculus? Khan Academy probably has some. I would imagine they do. They should have some. Okay, there we go. All right. So does that make sense, Sneaky? And interesting here. So when the slope of the velocity graph is positive, right? This slope is positive. It also depends where it is, okay? So if you're looking on your velocity graph... Thank you. Who just showed up? JC, thank you. I need you to hydrate. I ran a 5K this morning too. So if it's going from negative to 0, right? That means your velocity graph will be here, right? So this is, right, a positively sloped velocity graph, but the value of that velocity goes from negative to 0, right? That's this part. If it's still a positive sloped V versus T graph, but it's above the x-axis, this is going from 0 velocity to positive velocity. That needs to then represent this half of like the happy face of the U. Yeah. Does that kind of make sense? Here, if we like draw like, that's this part of it, of the happy face, and then this is this part of the happy face. And then it's kind of the same here. If you have a V versus T graph, but let's say the V versus T graph is negative, right? Or the slope of it's negative, right? So let's say this, right? So this goes from having negative, from having positive velocity to 0 velocity. So here, that's going to be from here to here. And that's this half of the sad face. And then if the velocity graph is still having a negative slope, but it's below the x-axis, that goes from having 0 velocity to negative velocity. And so that represents this part of the sad face, yeah. Cool. Or just look at the sign of the acceleration. Yeah, you can do that, but then you have to go like draw this as well. But yeah, this is also kind of an indicator of things. You're totally right, Alex. This is like concave up. This is concave down. And then this is, yeah, concave up. I've done videos on these. They're on my TikTok. They're one of like my first ones actually, like drawing velocity graphs and position graphs. I forget where you found us, if it was TikTok or YouTube, but if you go to my TikTok, if it wants to load today. And where did I do it? Yeah. Oh, here's how to graph f prime from f of x. That's kind of the same thing. Here we go. How to draw velocity versus time graphs. This is a really good video you should watch. And then I also go over like how to draw acceleration versus time graphs. This is another really good video. So try to go check these. And so this is drawing them from the position graphs. Yeah, so they're pretty good. Okay, cool. Does that make sense to you, Zion? This is a good. This is a very good overall like physics question. Yeah, you're very welcome, dude. Nice, great job. All off his back. All right. So I'm gonna post that in our Discord. This was Zion's question. Let me put it over. Nice. We already got 10 questions in the queue. This starts fast. Okay. All right. Zion's is done. Nice. And so, if you go over to our, not there, where is it? Yes, here, the homework help forum. Here's your question right here. And then what I'm going to do is I'm going to drag in the screenshot of the solution. So there's everything we worked on. So you can kind of go reference it later. And then you also get a bond coin, by the way. Congrats for asking a question. And those can be used to get gift cards and other fun stuff in our server. So nice. Your first one. Yes. What's up, Sadude? Thanks for all your solutions this weekend, Sadude. You've been great, dude. Sadude did a lot of great things. Where were you doing? Was it here? Or Joseph did this one. I think it was not that one. Where is it? This oh, I know. It's sorry. It's towards the top actually. This, yeah. Thanks, Sadude, for writing all of this up for this question. This was like a very difficult, like, I don't know if I could have done this one, but I appreciate you writing all this up for me. Thanks, dude.
My man.
Yeah, the 4A one too. Yeah, nice. Okay. Yes, catch him on Tuesday. Make sure you go follow him too, so you get notifications. Turn on the notifications and stuff. All right, let's see what the next question is. So if I go here and click on our live queue, I can see what we have so far. Questions from Sibley. That's my LinkedIn. I don't need my LinkedIn. Where is it? The question from Clickbait. Sorry, Sib, you asked a question too. I saw it too. Okay. Wait, is this the one Ramton's supposed to do? No, this is a different one. Okay, I'll attempt it. It just doesn't work on your computer. Oh no. Oh dear. Okay, let's see how far we can get on this. Let me get rid of my lines here. All right, two particles whose reduced mass mu interacts via a potential energy U equals 1/2 kr squared, where r is the distance between them. Make it a sketch whose reduced mass mu. The centrifugal potential energy and the effective potential energy. Okay. What is centrifugal potential energy? Sorry, what? Centrifugal? What? I know centrifugal forces, like centripetal acceleration. Clickbait's taking an upper division mechanics physics college class that sometimes gives me like heart attacks. Oh, okay. Here we go. We got some more information coming in. Really? Twitch? I use Edge just because I don't know. It's just I wanted like a clear browser. I don't have anything. Here, Clickbait says the equations are in the description. Great. The effective potential energy for a comet. Oh, this is kind of like astronomy stuff almost. Yes, so Sneaky, no, very very good point, because I know sometimes we're streaming really late for different people's time zones. So even if I tell people always submit the question regardless, because it'll get added to our Discord and someone may do it later. Yeah, that's astronomy, right? Yeah. Is my audio fucking again? Is it fucking up on Discord again? I don't know why. Discord needs to like get their shit together. Okay, Sneaky can hear me at least. Yeah. So yeah, I always tell students, even if we don't like get to your question live on the stream, it will get added to our Discord, and if I do it on the stream, the solution will get posted as well. Otherwise, one of my other awesome like friends here will probably just help you out and do it as well. You can hear me? Okay, great. Okay. Yeah, Discord's not the best sometimes, but I still stream there. Okay, good. I'm back. Okay. All right. I'm pretty lost on this one, clickbait. Like, what am I supposed to do? You gave me graphs. Find the equilibrium separation, the distance at which the two particles can circle each other. This requires du, df, dr to be equal to 0. Okay. Well, here's u. I get that. But then, where is UCF? Oh, UCF is equal to this. Okay, maybe actually... Sorry, maybe this isn't too bad. Okay. I think I got it. Okay, so U effective. The nebular hypothesis? Dude, that sounds wicked, dude. Okay, so I think UF is equal to this 1/2 KR squared. Is that what we're saying? Right? Plus plus UCF. What college major is this so I can avoid it? I think he's in... Sorry, what are you in, clickbait, by the way? What is this? Yeah, this is upper division classical mechanics. So this is not first year college physics. This is like second or third. Yeah, I'm pretty sure he's a physics major. This is tough. Okay, I feel like this is U effect. I mean, just based on the graph. I've never seen a centrifugal term. I don't know what the fuck this is. I can do circuit analysis if it's not too crazy. And yes, I can definitely do related rates. I love related rates. One sec, I'm checking ChatGPT for some of this just to like see where we're going. I don't want to start doing Taylor expansions on things that are like not correct. Yeah, third year physics. Yeah. This is a brutal class. I understand it. Looks awful when I searched it up. Good luck. Yeah. If I was closer, like I did this probably in 2013 is when I was in like upper division classical mechanics. So it's been 12 years and I rarely get asked these types of questions on my streams, but I appreciate them. They're cool. Yeah, you have U. Well, is this U effective, JC, by the way? That's my question. I'm gonna assume it is. Okay, yeah, let's just fucking do it. Yeah, all right, fine. So, du dr, that's just gonna be equal to kr, and then this is gonna be plus negative 1/2 L squared over 2 mu r to the third, right? I mean, I think it's UF. Again, I'm going based on this other picture down here that said the UF that governs the radial motion of a comet. is the sum of its gravitational potential energy, which I think here is what they're talking about, potential energy. And then they say, and the centrifugal term. Apparently this is the centrifugal term. I don't know what L signifies. I'm so glad I don't need to take that, yeah. Okay. I actually scrolled down and saw someone gambling. We're basically gambling with our lives here. Okay. So, let's just set this equal to 0, right? I'm pretty sure we can just figure this out, yeah? Let's do it. Yeah, I'm not sure what L is, but we'll figure it out. So, okay. I get that KR is equal to -1/4 L squared over mu R cubed. So then I can move the R cubed over, divide the K over. So I get R to the 4th is equal to -1/4 L squared over K, over mu K, right? And then I just need to take the 4th root of this, right? Oh, I'm sorry, this is plus. Sorry, no negative. L is angular momentum, imaginary distance, we're cooked. Yeah, no, I screwed up. Yeah, sorry. When I move this over to this side, it's a plus. Yeah, we're good. Okay, cool. So L squared over 4 mu K to the 1/4. Nice. Okay, now we could take the second derivative, right? In order to see whether this is a maximum or minimum. Yeah, I think we agree it's angular momentum. Okay, so d squared mu dr squared. That's another derivative of this. So that's just going to be equal to k, right? Because the derivative of kr is just k. And then that's going to be positive plus 1/12 L squared over 2 mu r to the 4th. Oh, very cool. This will always be positive. Okay. And if your second derivative is positive, that tells me we're concave up. So yeah, this must be a minimum now. So local min. Yeah, concave up. Okay, cool. So that must be stable at some point, right? Still locked in. I do not know PDEs. I know ODEs. PDEs, we do have another... We have a lot of awesome math streamers that you should go check out. There they are. So there's all their Twitches. Go follow them as well. How often do I stream? 5 days a week. Again, if you ever want to figure out when we stream, go to actualofficehours.com and then just click here on the streaming schedule, and you can see all the different times that we stream, and also the other times our friends stream. Like, so Penn Center is going to have a data science stream after this at 6 in a couple hours, and then JC's streaming Tuesday morning. We'll stream tomorrow. Zach's streaming in the afternoon. There's a lot. All right. Okay, so we did part A, I think, right? Or we did part B. Does it want me to do... So the graph... I mean, I guess you're just graphing these three things. That shouldn't be too hard to draw, right? That's just like this, and I guess that's... yeah, whatever. Something like that. And then U effective, yeah, has this minimum... okay, so I think it does look like this then, right? Yeah. So that's like right here. That's cool. How do I integrate for air resistance? Carefully. Yeah, number 9 in the queue, yeah. If you want to skip the queue and you're on Twitch, you can buy the Me First perk using channel points. Or if you do a super chat donation to our nonprofit, I'll let you move up in the queue as well. But otherwise, yeah, if it's just hang around. We'll get to it, don't worry. Okay. By making a Taylor expansion of U effective around the equilibrium point R naught and neglecting all terms higher than R to the third, find the frequency of small oscillations. Ooh, that's cool. Okay, so U
effective is equal to this. Thanks, JC, for the baby voice. Oh, nice, Justin. You got do they have the wristbands that light up? Yeah. I do not do the daily integral, but someone has shown me that before. It is very cool. Here, I'm gonna do some things for this. Ah, fuck.
Sorry. Okay, I need this, because then we're gonna Taylor expand. No. It's because on Twitch, people can buy a perk to change my voice. So yeah, my voice is pitched up for 30 seconds. Twitch has a lot more fun stuff for people to like interact with the stream. I don't know how to do it on YouTube. I don't think YouTube has like a perk system yet. Yeah. Nice, yeah. And then there's Master Chief comes out too. Yeah. Okay, so if we can ignore R to the third and higher, I think we only need the first and second derivative then, right? So I think this is all we need, right? Because a Taylor series, up to third order, right? And they want it about R naught, right? So F R naught, Taylor expanded, is gonna be F0 at R naught, and then it's gonna be I think it's just that, right? Plus F prime R naught, and then it's R minus R naught over, is that 1 factorial? Finally, some break from scary math. Thank you, Dr. Gold, for reminding me that math was once fun. Thanks, dude. Yeah, the tangent line is a Taylor series of degree 1. How neat. Yeah. Yeah, it is pretty cool. Yeah, no, Taylor series are really fucking dope. Taylor series are really cool. Once you, like, understand, like, what they're doing. And then this is over 2 factorial. Right? So this is the Taylor series, I believe, right? This is a Taylor series. Up to order 2. Okay. Right. Taylor expansion of U effective. Find the frequency of small oscillations, yeah. Math is fun, writing is not. Yeah. Math is still kind of fun if you want to excessively damage your brain. Oh dear. Okay. Alright. So, and sorry, this is F of R, technically is what this is. F of R centered around R naught is what I meant to say. That's a Taylor series. So it's the 0th derivative, which is just the regular function. So that's going to be this, but then it's at R naught, right? I'm not going to sub in the R naught yet. Okay. Plus the first derivative, so that's this. Right? Times R minus R naught. And then plus the second derivative, which is this. R minus R naught squared, and then this is over 2 factorial. So just over 2. Okay, cool. That's F of R. And then what are you supposed to do next? I think you just expand all this garbage. Right? Oh, but wait, here's... Wait. Yeah. Oh, but here's the interesting thing. Ooh. You want to see something cool here? Clickbait? We already determined what this is going to be 0. Because when we plug in, sorry, this is at R0, right? This is also, sorry, R0. When I plug in R0 for this, we literally set this equal to 0 to get R0. Yeah. Yeah. This whole term here goes away. That's super cool. Yeah, so this is gone. Yeah, submit your question, is that I'll get to it today. Because at R equals R0, F prime of R0 is equal to 0. Or F prime of R is equal to 0, yeah. That's so cool. Nice. Okay, cool. Right. Very cool, very cool. Super dope. Actualofficehours.com is how you do it. Yeah. Okay, now here's kind of the cool thing.
Nice.
Yeah, again, I'm kind of borrowing ChatGPT for inspiration here, but this does make sense. If you would Taylor expand to the second order, right? We know that for a spring, right? Mu is equal to 1/2 k x squared. Right? And so this part right here ends up being this. Right? And then, right, omega is equal to square root of k over m. Which I think in this case will be square root of k over mu. Right? Uh-huh. So I think we just take this part here to be equal to k. So we say, yeah, for small oscillations, for small 1/2 k delta x squared over 2. Yeah, exactly, Sebastian. That's what this is, right? And this right here, look, this, yeah, sorry, it is technically delta x. Yeah, you're right. This is like x minus x naught squared, right? And this part right here is literally the same thing as this. Okay. So that tells me that k is equal to this second part, which is kind of gross. Right? Oh, wait. And sorry, I made a little mistake here. Okay, sorry. I did like the integration here. Sorry, the 2 comes down on the top here. Oh, okay, one sec. This was a bug. Watch what happens. Sorry. This was a 2. This cancels. Got it. And now this becomes a 3. Okay. Yeah, okay. Let me fix that. Sorry, I screwed this up. There we go. Yes. I make mistakes too. Okay. So this is gone. And again, this is why I do like ChatGPT is great for like checking like simple algebra errors that I'm making. I'm just like, this is dumb. Yes. Yes. Yeah, yeah, yep. Okay. Okay, so yeah, now we're here. Sorry, this wasn't 1/12, right? This is just L squared over mu... And wait, was it R naught to the 4th? Yes, right? Second derivative to the 4th. Uh-huh. Okay, cool. I can definitely do Calc 1, yeah. Sorry, and then this is R naught. I can try Soul Cheetah, and if I can't do it, it'll get added to our queue of questions. Oh fuck. Man, this question will be the death of me. Clickbait, you're always giving me the fucking heaters, dude. Okay. Alright. And I think there's a fucking 3 somewhere. Yes, there's a 3 here. Good. Okay. Now, alright, watch. This goes into here. And so we're going to get is equal to... Dr. Gold crash out in the big 25. Okay. All right, this is K plus 3L squared over mu, and then this flips because it's... No, yes, it does flip. So then this is L squared mu K. Okay, so this all goes away, right? This cancels. Okay, so you get this equal to 4K. Okay, cool. All right, yes. Okay. So great. So K, which is equal to the square root of... Wait. So square root of K over M, this is like K effective, is equal to omega. So that's equal to the square root of 4K. Instead of M, we have mu. So we have 2 square root of K over mu. Okay, nice. And then we're done. Okay, great. Awesome. Okay. Yes, well, we can get Desmos to do the sketching. What's up, Justin? You're gonna show us? Justin's at a game. Ooh, wow, this is an NFL game, dude. Sick, bro. Very cool. He says thumbs up, dude. Nice. Not many people in the stands, though. Interesting. Oh, he's got a wristband. That's cool, Justin.
7 o'clock, that's why.
Oh, are you there early for the game? I think he's early for the game. Yeah, he says early. Nice. That's cool. I think it's his first NFL game, too. That's really cool, Justin. Okay, great. We did that question. Took not too much time. It's only like 25 minutes. Pretty good. Let's mark it as done. Let's download it. Thanks, Clickbait. Yeah, I thought that was going to be scarier than it actually was. Mainly, I get scared whenever I see like 3 stars. Because usually the stars signify it's going to be like a really hard question. But it actually wasn't that bad. And I thought it was really cool how the Taylor series, you got rid of the middle term because, yeah, the derivative was equal to 0. That's super fun. Good question, Clickbait. Alright, let's see what we got next. I left to go to the bathroom. Why do I see a football game? One of my students was at an NFL game and he wanted to show. So I said, cool. Poison Mouse, what do you got for me? Polarization? Okay, we're doing some physics now. We've been doing physics. Well, I feel like that was almost math. H4 says, I have a test on classical mechanics tomorrow. You did this one yesterday? Oh, wow. Oh, that's cool. Are you in the same class as Clickbait? Are you guys doing the same stuff? Boom, boom, boom. All right. All right, next question. Poison Mouse. What do you got for me? A square plate is made of dielectric material of D equals that, height, L equals that. Okay, has... Okay. Wait, the polarization is not uniform. Great. A and B are that. Determine the total surface polarization charge distributed on the surface of the plate. Sum of the surface charges on all faces. Express the result in C, but without writing the units, using 2 decimal places and scientific notation. Great. Estás yendo a la católica? What? Something Catholic. You are something... Oh, you're from Chile. Oh, sorry, you're at a university. Oh, that's cool. Give me gold. Oh, you're giving me a headache, though. Oh, the time changed, yeah. Do I have to do a Lagrangian? I don't think I need to. I think it's just a simple E&M question, no? Isn't like sigma equal to... So, okay, interesting. So, okay, we got some cool stuff here. First of all, P only points in the y direction, no? Right? I think the equation is that sigma is equal to P dot n hat, right? But P only points in the y hat direction, so I only care about surfaces that point in the y hat direction, or that have normal surfaces to the y hat direction. Cool. Yeah, okay, so I only care about this face and this face, right? Fuck all the other faces. Right? Because this points in the z direction, this points in the x direction, this points in the x direction. Okay, sick. Okay. And then, yeah, none of this depends on z. Yeah, it's like a flux. Yeah, Femvox, it's like a flux. And interesting, yeah, this only depends on y. Oh, so I don't even need to integrate. So if this depended on like x, then if I did like let's say like d this was equal to like dp dot n hat, then this would have to be like whatever the p is dA, and then that would have to be like dx dy. But this thing does not depend on anything x or z. Sorry, it would be dx dz. Right, this would be p of y dx dz, but this thing only depends on y. Oh, so this is super easy. Okay, cool. All right. So, I just need the area. Right? Okay, show the work, bro. Fine. Okay, so area equals L times D. Which I'm just going to leave it as what it is. And then you have to do the two faces. So on the first face, n hat points in the positive y direction. And then, wait, did they tell me what? Wait, a distance d that. Wait, yeah, but where is this? How high up is it? I need the height of this box, dog. Dude, L in this diagram is not a height. Oh, it's a square. Oh, God. I'm retarded.
No, God!
Okay. All right. Yeah. All right, dude. Okay, cool. This is L over 2. Okay. So, I'm just gonna leave that as LD. Okay. So then, P at L over 2, that's gonna be equal to A L over 2 cubed plus B, right? And then so P at negative L over 2 is going to equal to A negative L over 2 cubed. Really? For an hour? Dude, I think this is just easy, no? And then you just dot it with n hat, dude, but n hat is y hat. In this case, there's a negative 1, and this comes from like n hat is equal to negative y hat, right? There's a polarized algebraic variety. Oh Jesus, you guys need to chill.
Disqualified.
Stop. Why are you guys hurting each other so much? Okay. Cool. And then what? You just multiply this by A? And just multiply this by A? Things almost cancel completely. B certainly cancels. I don't need B. No, P is a vector. Yeah, P is for sure a vector. Well, look, because they tell you it's along the y hat axis. Yeah. Okay. So, one sec. TikTok's making me ensure that I'm a real person. You got the right answer from it too, still? Okay. So, okay. Right, top plus bottom. So it's that, and then it's minus this. Right, but then this has a negative L over 2 in it. Okay, so the B goes away. Right, I don't even need this. This cancels with this. And then minus will become a positive. You want some gold to see if it works? Okay, cool. So what? That's, A times big A, and then that's, L over 8 plus L over 8, so it's L over 4. L cubed over 4. Alright, what are my numbers? On here, let's get A equals L times E. No, your joke, I love your jokes, Poison. Chill, dude. You're fine, dog. Let me get my calculator out. I'm here for all the gold, dude. All right. L was 24.4 e to the minus 3. And then we multiply that by 3.6 times 10 to the minus 3. Right? So that's area. So 8.78. Cool. Poison Mouse, I wrote it as L over 4, D over 4, which is almost the same as A. Yeah, exactly. Okay, cool. And then I multiply that by A. So that's 1 e to the minus 2, right? And then I'm going to divide that by 4. And then I'm going to multiply it by L cubed. So you should get 3.19 microcoulombs. No, picocoulombs. Yeah, because it's 10 to the minus 12, right? Got the same answer? Nice. Great. Love it.
That's dope.
Thank you, Olaf. Yeah, I appreciate Olaf. Alright, mark that one as done. Poison, you're gonna get some gold for this. You know that, right? Watchdog. So we got your screenshot in here, right? We're gonna post it. And here, I'm gonna give you some gold right now. Wow, Poison. Look, you got your first gold. Your professor says it's 0. Tell them they forgot the minus sign. They forgot that n hat points in the negative y hat direction here. Let's do a real analysis proof.
Oh no.
I can't really do real analysis, but I have other math streamers that can do real analysis if you want to maybe hop on their streams. They do stream later this week. I failed 3 times because it says it's 0. Well, dude, sometimes the solutions manual is wrong. Real analysis is fake.
No.
Is it fake? I never took it. What's up? Let me remember. Zhongju. Oh man, what's your real name or your white name? Fuck. Sorry, Sup. I totally forgot. Jaden. Your name's Jaden. Yes, that's it. All right, thank you. Oh, yeah, you hated it? No, I agree, SS. Yeah, that's pretty brutal, dude. All right, let's see what we got next. We got a question from Shane. Love this. Thank you, Shane, for giving us some fun math to go through. Okay. Solve the following inequality using sign analysis. Okay, this is great. So whenever this happens, the first thing I want to do is I want to find the zeros. Couple ways to do this. I could factor it. I'm going to factor it. So I'm going to do this times this. So that's minus 6 times 3, which is going to give me negative 18. And then I need factors of negative 18 that add up to negative 7. And so that's going to be negative 9 and positive 2. And then I'm going to show the gold method for factoring. So negative 9x, 2x, negative 6x squared, 3. And then we're just going to factor. So out of this, biggest thing I can pull out is a 2x. Gold's rule mentioned, yes. We're calling it the gold rule. Dude, no one else has called it anything else, so I'm claiming it. All right. So then, when we look at this one, that's going to be 3. And then, yeah, here, that's just 1. Cool. All right, so now you got your factors, right? So we got 2x plus 3, and then I'm going to say 1 minus 3x is less than or equal to 0. Okay, so the roots at x equals negative 3 halves, right? Because that's what causes this one to be 0. And 1/3, because that's what causes this to be 0. All right, so let's draw some things. Okay, and then because it's a less than or equal to, those are gonna be solid circles. Okay, so this is gonna be 1/3, and then we have negative 3 halves. Do you use Sketchbook Pro? I don't. I use a thing called Group World. You never learned this, Jack Johnson? Yeah, it's the gold method. It's just an easy way to factor when the first coefficient isn't 1. It's basically the grouping method, but I find it a little bit easier to like work with than like having to, especially when there are negatives involved. It's called the gold method. Well, I haven't seen anyone call it anything else, so I'm calling it the gold method. All right, all good. RN, thanks for coming by. Okay. Isn't it? Yeah, right. I would have done so well. Okay, the next thing to do. So once you have your zeros, we have to check in between the zeros. So, I mean, 0 is a great point to check. All right, so let's plug in 0, right? So if I plug in x equals 0 into here. Okay. This is a positive number. This is a positive number. Is a positive times a positive less than 0? It's not. No. Okay. So that tells me that it's not here. Okay, so now I basically know it's here, in here. Because if it's not there, it's got to be on the other two sides. I mean, we could be safe, though. We could check another number out here. So we could check, for instance, like -2. I don't know why this showed up. So let's just check it just for shits and giggles, right? Okay, so for -2, this is -4 plus 3. That's negative. And this is positive. Positive times a negative is negative. It's less than 0. Check. And then let's just pick another number. Let's do like x equals 5. Or x equals 1 should work, actually, right? So that's 1. That's 1. So this is now a positive times a negative. And that's also negative. So that checks. And thus, this region is okay. And then this region is also okay. And you're done. Nice. Cool question. Thank you for that. Oh, wow. Oh, sign charts. Yeah. I've done a lot of those before. Whose question was this? That was Shane. Thank you, Shane. I'm gonna mark that as done for Shane. And then let's drag it in from. How's my Gen Chem? I'm really good at Gen Chem. I can definitely tutor Gen Chem. Yeah. For sure. Okay, next up on the list is Scrimblow. Let's see what Scrimblow's got for us. Ooh, simplify the expression. Kinda like this. This is fundamental theorem of calculus, no? It's actually a really easy one to do. What is that, lineatrix? Eusegian integral? The hell? Femvox is eternally our solutions manual. Oh, one second. These. Oh, okay. All right, this is fun. Oh, you come up with your own method, lineatrix, so that's cool. Thank you. Thank you, Republic. Yes. This is super easy. So whenever you have the derivative of an integral, all you do is you just plug this in for the value. Do you plug in the 5 as well? No, right? Because this is a constant. If this was like x squared, you then also have to multiply it by like 2x. But since this is just x, this is just going to be equal to 5x squared plus x plus 2. Yeah, so this just comes into here. And then it's technically all times derivative of x dx, which is just 1. Right? And that's just equal to 1. Nice. Cool. Yeah, that's a really nice one to do. What happens to the constant? So yeah, if you were to integrate this, right, you would get what is this? This is like 5t. Here, we can show you why that is. Do you want to see why it is? Because you could go ahead and actually just do this integral, right? What's the integral of 5t squared plus t plus 2 dt, right? That would just be 5t to the third over 3 plus t squared over 2 plus 2 t, right? And then that's integrated, right, from 5 to x, okay? So yeah, let's just do the integral part first, and then I'll show you how this works. So this would be 5x cubed over 3 plus x squared over 2 plus 2x minus 5 times 5 cubed is 125 over 3 plus 25 over 2 plus 10. But then remember, from this thing, right? We're still doing ddx of the whole thing, okay? This stuff is just a number, right? And the derivative of something that's just a number, a constant, this goes to 0. And then when I go ahead and take the derivative here, watch what happens. So the 3 is going to come down, cancel that. So I'm going to get 5x squared plus 2x over 2, right? So this is 5x squared, 3 times 5x squared over 3. Yeah, right? Yeah, it becomes the same thing. Plus 2, which is literally what this was. Yeah. It's pretty cool. Yeah. And so, yeah, that's your final answer. Nice. Good question there. Thanks, Scribbo. Yeah, and that's also why that's also why I was wondering for a second. I was like, wait a minute, do I care? Usually it's written with this thing being 0. But even if it's 5, right? You're still just getting a constant. Oh, you're very welcome. Good night. Good night, Poison Mouse. Yeah, it's pretty cool. Usually that integral is not something easy to do. And that's why you use that's called the fundamental theorem of calculus. To you just plug in what it is. Okay, let's see who we got next. Smog, what do you got for me, Smog? Oh, Jesus Christ. No. Isn't it easier to think of a derivative as just the opposite integral? Yeah, it's an well, integral is an antiderivative, so derivative is like an anti-integral. Yeah. But like sometimes the thing with the bounds like makes like some shit happen. Okay, what the fuck is this question, Smog, dude? Okay, sand of density, fluid mechanics. Okay, I don't know if I can do fluid mechanics. I haven't taken fluids. Neglecting the rate of change of the momentum. Calculate the tension in the rope mooring the barge, assuming that the rope is horizontal. Lastly, determine the depth of the barge. If the cylinder... What? Ugh. Arc integral. I love that lineatrix. Okay, I don't know how to do this one, Smog, and in the amount of time I have left, I'm not gonna be able to figure it out. So I'm gonna punt this one off to. Hopefully, we have other engineering people in our Discord that can maybe do this. But I gotta leverage my strengths, what I'm good at. I've never done fluid mechanics, and I'm not about to learn tonight. But here, I will give it the unsolved tag. I do have a lot of engineers that maybe want to like help out, and so I'm gonna come up with like some tags for like engineering gods who want to do, because again, all of it, all the stuff is based on physics. At some point, engineering just tends to come up with like some cute shortcuts for it. Like there is kind of a related rates thing happening here, right? But then the change in moment. Yeah, wait. There's tension in the rope, right? Because you're pushing mass at some like dx. And then, oh man, right? The force. Is this where like impulse comes into play? Like F delta t has to equal the other change in momentum, because you need the total change in momentum to be 0. So you need the sum of the forces to be 0. And then the forces, I mean, I can like show somewhat of what happens. Where was it? I'll give like some thoughts on this, because you're probably along the right way here. But in my mind, because you're having a changing momentum in the x direction, right? Because you're having more mass getting pushed out to the x, right? So F is equal to ma, right? Momentum is equal to mv. So if you do dp dt of both sides here, now you get ddt of mv, which kind of looks like mdvdt, which kind of looks like ma, right? So this is why sometimes we'll say that force is equal to dp dt. So if you can figure out what the change in the momentum is over the change in time, which they do give you a rate, right? They say discharging the sand at speed u. And then there's... see, but the mass is changing too. Yes, I know Kramer's rule. Yeah. But then, wait, they also say neglecting the rate of change of momentum. Wait, isn't that what this is? This is exactly where I'd be trying to go with this. What? All right, here. Let's just send this bitch to ChatGPT. Yeah. Come on, chat. Solve me. Solve things for me. Solve. Let's see what it says. I like to just see the inspiration for what it thinks we want to do for it. I wouldn't be surprised if ChatGPT in their early days bought a Chegg account and just fucking data dumped all their solutions. Because this probably comes up on Chegg somewhere. But now Chegg is like firing half their workforce. Yeah, okay, so do you see how it says, should I involve impulse? Tricky. Right? Yeah. Because where I start thinking about things, right, is that, so delta P is equal to F delta T. Right? That comes from this. And this is like F average. And so you have to figure out what the change in the momentum is. Okay, so here we go. It's doing some stuff. Well, it fucked up the LaTeX. Fix the LaTeX, please. Okay. M is equal to rho pi r squared mu. So I agree with this, right? M dot, because rho is your density. Pi r squared is like the surface area of the pipe. And then mu is your flow. So this is like a mass flux. Right? So then M is equal to M naught plus M dot T. Cool. Neglecting the rate of change of momentum of the barge itself, the horizontal force equals the momentum flux of the incoming sand, which I think you were correct here, right? This, well, I don't know why you wrote sine theta, right? This should be cosine theta. Oh, you did write it. Okay, yeah. Okay. And then there's your expression for M dot, right? Oh, okay, cool. And then if the barge is a horizontal cylinder radius r and the water line is that, okay, then yes, this is cool. So then in order for the buoyancy to work, right, you need the buoyant force, which is rho g ah has to equal mg. Technically there's another like term there. It is fluids. Oh, this is where this like starts to mess me, dude. What? The cross-sectional area of the submerged circular cylinder is what? Dude, where the fuck is that coming from? No. Okay. Alright, I at least get part A. I get part A. This to me makes sense. And this comes from, again, from impulse. Oh, where comes the mass flux? Okay, well, okay, so here, mass flux. This is just equal to like, this is just dm dt, right? So change in mass over change in time, which is going to be equal to like mass times velocity. right? Because, well, let me think how. Sorry. Let me think how I think about this. It's like cross-sectional. So it's okay. So mass, right? Mass equals density times volume. We agree with that, right? This is volume. So if you want to do d mass, d time, right? That's rho. So that's here. Let me move this. There you go. So that's ddt volume, which is going to be area. This is like cross-sectional area. And then this is times like thickness. So like usually times like thickness. Which, okay, assuming that the cross-sectional area doesn't change and the momentum and sorry, the density doesn't change, right? This is rho a cross-sectional, and then it's ddt of the thickness. Which, if you were to look at this again in terms of this, right? Think about like a cylindrical little piece of sand, right? This has a cross-sectional area, AC, and then it has a thickness here equal to X. But if this sand in the pipe is moving with a velocity V, then you can say that dx dt is equal to V. And this is like the thickness. So that's why this becomes rho ACV. Yes. Well, no, thickness is the same as V. Well, yeah, velocity, right? Which in this case is equal to U, right? Because that's what they say. They say it's discharging at a speed U. Yeah, exactly. Yeah, you just think about like a chunk. Right. And that's why here, so yeah, this here, let me just do. Yeah. Nick says, I like using U as the velocity component since the X direction usually picks the U vector. I mean, that's correct, yeah. And then this is interesting where they're doing this. So, yeah, this is so cool. Okay, so then let me show you where this comes from. Yes, mass flux will always be density, area, and velocity. Yes, assuming then again that the cross-sectional area is not changing as you go across some like thickness X, and then also assuming the density is not changing. Yeah, for sure. Okay, so let's think about like what the volume of like a chunk of sand in this pipe would be, right? Volume would be equal to AC times X, right? It would be this cross-sectional area times like how thick that cross-sectional area extends in the pipe. And then if you want to know the mass, right, that's rho times the volume. And then if you want to know how much of that is changing per unit time, okay, well then it's the amount of it's the amount, this is dx dt. It's because that's how much the thickness is changing in the pipe. If that makes sense. It's a little hard to think about. Yeah, if you like stopped like time, took a snapshot, right? The volume would be equal to this cross-sectional area times like how the length of the pipe you're looking at. If you want to know how much of that is changing per unit time, well, the cross-sectional area is not changing, the density is not changing, but how thick this pipe is, how long the pipe is, like the mass you're looking at, that is moving through at the velocity U in this case, which I mean I was calling V. You do this also in E&M whenever you have this is the classic question they do. You have something like this and you have like a bunch of magnetic field here. And then this is how they create a railgun, by the way. And then you have like a piece of wire here, right? And then you discharge a current through it. And then when you do that, this thing ends up like rocketing in a certain direction. And then that's because you have like magnetic flux dt, right, is equal to like the EMF in it. And what you end up figuring out is that magnetic flux, right, is equal to you would say x times y, right? Because times b. But then the amount of area that's there that's changing, so ddt is equal to the derivative of xy that you're enclosing. Y does not change, but then dx dt is the same thing as the velocity of the bar moving to the right. You'll see this in E&M. That's an E&M thing that comes up. But okay, but then this part, right? This is what I was talking about, right? So, F is equal to dp dt, right? And in this case, dp dt is equal to but then it has to be in the same direction, right? So the momentum is changing in the x direction by m dot u, right? Because, okay, dp dt is equal to ddt of mv. You assume that the velocity is not changing, so that's v dm dt, and then dm dt is what you figured out up here, the PACU. So this is density cross-sectional area, which is pi r squared, and then times u. And then, but this is also u, right? The v is u. So that's why you get, and then there's a cosine theta on it because you only want the component of the momentum that's changing in the x direction. So then you get that, right, F is equal to rho pi r squared u squared cosine theta. Yeah, you see that? Yeah, that's pretty cool. Actually, so this question isn't the absolute worst. Sorry, yeah, Ratchet, yeah, actualofficehours.com is the best way to submit your question. Yes. So that part's not too bad. This part, how do we know if it needs mass flux or not? Anytime the mass is like changing, or like mass is getting deposited somewhere, and you're asking about like what force is that creating, that's when you need like mass flux. I mean, fluids is a lot of like mass flux stuff. Actualofficehours.com. Yeah, there's a screenshot. You go to this website, and then you just drag your screenshot in. Rush sheet. Yeah. Yeah. Yes, it's like a force. Yeah. It is a force. Yeah. Especially like what kind of like turned me on to that dp dt is the second I saw a tension. Anytime I see like tension's a force, and then I know from physics that F is usually dp dt. And so if you have a changing momentum of sand coming in, that's going to create an opposing force to stop that. Because otherwise, if you just dump sand in this thing's just going to keep moving to the right. Will this include friction? No, because momentum is not conserved with friction. Right? Yeah, I don't think you can do this if there's friction involved. Right. And then the depth of the cylinder. So I agree. This is just doing whoever's law it is, the buoyancy law. I fucking forget the guy's name, but basically just says that like rho water GV has to be equal. So the buoyant force is equal to the mass of the water that you're displacing, and that's rho G AH. Technically times H as well. But that's equal to the mass of the barge times G, also times the height that's like displaced. And then, yeah, the cross-sectional area of the submerged circular segment, I do not know where this arc cosine thing's coming from. I think that might be wrong. Yeah. I don't know where this is coming from. This I think is probably ChatGPT just having like hallucinations based on, they're probably looking at this being like angled and stuff, which is not. So actually I think this is easier than it's supposed to be. Right? Yeah, I think it's hallucinating. So here, let me just do this last part. This part's... Oh, good, JC. Yeah, thank you. No, JC's right. JC's totally right. Yeah. Okay, so this is buoyancy. So this is part B. So by buoyancy, yeah, rho G A, and then this should be like, this should also be the height times the height. Because this is like the cross-section area. Yeah. And this is also times the height, but they're just canceling it off. Okay. And then you could technically cancel the G's off as well. So then you get to here. Right? And then A is equal to pi r squared. So this goes away as well. Good luck on your exam, Abakai. Yeah, good luck, good luck. Okay, so this goes away. This goes away. Oh, okay, so this is not really hard at all. Sorry, what was the question even asking, dude? What? Determine the depth of the barge H if the barge is a cylinder. Okay, one sec. Oh, isn't it just... Yo, bro, what? Why does it say... Why does it say... Wait, but you're adding M naught, so how can you cancel out the area? Correct. Yes, thank you. You're so right. Thank you. I can't do that. I can't do it. Okay. Right, so rho... Yeah. Oh, also, I can't cancel out the H then, right? Sorry, let me see here. Yeah, ChatGPT is like really fucking up on this. Actually, let's not use any of this. This is just so wrong. I was like, what? ChatGPT is having a very bad time on this question. Right here. It was good for inspiration, though. I did need to know it for this. Okay, so by buoyancy. Rho GV. So rho water has to be equal to we say like, I'm gonna say like big MG, and then this is gonna be like the sand. Wait, is there an initial mass for the boat as well? Sorry. The initial mass of the barge is M naught. Okay. Okay. So this is sand plus barge. Okay. So you get rho W, G, and then this is going to be pi r squared times H has to be equal to M naught G, because that's the barge, and then we say plus plus the mass flux, which was, yeah, plus U. Wait. Right, this is it. Okay. Plus rho ACU times T. Okay, right? Because this is like, this is dMdt, and this is times T. This is why we don't use LLMs. Yeah, with some things. I mean, again, it's good for the inspiration. But honestly, and there's a lot of learning in being able to tell when the LLM is wrong. Yeah, well, see, Lauren, if we used ChatGPT, we would end up getting the wrong answer. This is not correct. Okay, cool. Yeah, and now you're done. Okay, because now you just solve for H. Right? So H is equal to, and then, wait, I think this has a G on it as well. Yeah, okay, so all the G's go away. We can actually at least cancel the G's, right? Because gravity's constant. Yeah, we found tension. No. The tension was, I agree. The tension's just this. ChatGPT didn't screw up on that. Yeah, this is the tension. This is part A. And then I think this is just this. I think it's, M naught, pi r squared, rho, ut. And then all of this is all over, rho water, pi r squared. Cool. Yeah, I think that's it. Nice. Cool. Good question, Smog. I initially wanted to punt on it, but then ChatGPT like assured me it wasn't that bad. Yeah, but Chegg is late to the game. They're fucked up. They fucked up. They got in too late. Chegg was great, dude. Believe me, I had a subscription to Chegg. I paid for Chegg for probably close to 5 to 6 years because as a tutor, it's really great to be able to like check your answers and at least see the inspiration for like where the solution is going. But then yeah, AI kind of just made it obsolete, and they were a little too late to integrate it into their stuff. Nice. Okay, good. Great question, Smog. That was cool. It looked scarier than I thought it was. Actually, wasn't that bad. Okay. How do you send a problem? Actualofficehours.com. That website down there. Go send a question. You will see this website. Just put in your username, whatever, and then drag and drop it in. Hit upload. Make sure you join our Discord because I'll post the solutions to it in Discord. If I don't get to it, because we have an hour and 8 minutes left on this stream, if I don't get to it, it'll still get posted to our Discord. And then I have a wonderful group of other educators who may answer it like in their free time. So cool. And then yeah, you can also see the calendar for like when other people stream. So we have a lot of really awesome friends who are also streamers. All right, so let's see. Sneaky, what do you got for me? Oh, I like this. Oh, we got a probability question coming up from Sneaky. Okay, cool. Okay, here we go. The probability that a particular salesman will leave his sunglasses behind in any store is 1/5. Suppose a salesman visits 2 stores in succession and leaves his sunglasses behind in one of them. What is the probability that he left it in the first store? Is this like one of those the goats and the doors question, dude, or something? So I believe this is like a Bayes law question, right? So I want to know the probability of the first, given that I know he left it, right? So the probability of leaving, is this a Bayes law question? I feel like it is. What is Bayes law again? Sorry. Or it's conditional probability. There, this is what I want. You did it with a tree diagram. Oh, you could do that too. I think it's just Bayes law. Right? So probability he left in the first store, given that we know he left it in one of them, right? So this is like A, and then this is B. So the probability that he leaves it in exactly one of them, right? That has to be equal to the probability that you left it in the first one and then you don't leave it in the second one. Which, wait a minute, if you leave it in the first one, you can't leave it in the second one, right? Right? So isn't it just 1/5 plus 4/5 times 1/5? Because you either leave it in the first one and then cool, I don't really care about the second one, because these are not independent events. And then you either had to not leave it in the first one and then leave it in the second. So that's a probability you leave it. The probability of leaving it in the first one is equal to 1/5. And wait, the probability of leaving it in the second one. Well, actually, we don't need the probability, right? We just need. Yeah. Okay. Okay. So this here, this is PB. This is PA. Right. So then, the probability of B given A. So the probability that you left it, given you left it in the first one. Well, that's just 1. Right? So then it's just equal to PA over PB. Okay, this is kind of silly. Okay, so then this is 1/5 all over 1/5 plus 4/25. So what's that? That's 5 over 25? Okay. So 1/5 over 9 over 25. Dividing fractions easy as pi, flip the second and multiply. So 25 over 9 times 1/5. So 5/9. Cool. Yeah, same answer? Yeah, nice. Oh, that was cool. Good. Great question. Yeah. Tree diagram probably could have worked as well. I agree. Could have done a tree diagram. Nightmare says, hey, man, I don't know if you remember me, but I recently took the ASVAB after studying with you for a bit and just scored a 60. Nice, dude. Congrats, dude. You get shipped January 12th. Nice. Remind me what branch of the military are you going into? The ASVAB, for those that are wondering, is like the military SAT, basically. That you have to like pass to get accepted into our wonderful armed forces. Navy. Oh, yeah, in the Navy. That's cool, dude. One of my best friends who I work out with every day, he was a Marine. He did, I think, 2 tours in Afghanistan, and we always joke, right? Marines stands for my ass rides in Navy equipment. Yeah. You want to see the answer? Yeah, this is the answer. And then also, do some further math stats, bro. I just started this year. Nice. That'll be fun, Nightmare. Do you know where they're shipping you off to? Are you gonna go fight in Venezuela? Like, what's happening? I don't know, like, which war, like, the U.S. is getting involved with next, honestly. Whose question was this, by the way? Why would you go into the military for a government which is enforcing some not so good things? Because there's a lot of perks. So, in exchange for, like, risking your life and, like, severe, you know, damage to your health and whatnot, you do get room and board. You do get health insurance, which, you know, I currently have to pay a fuck ton for. Sucks. So the military is great because you get the VA. Yeah, I mean, you can have ethical arguments about, like, why you don't agree with, like, what the military does, especially, like, again, I'm not the biggest fan of Trump, but I think notwithstanding those things, it is important for our country to have an armed forces, and recruitment was at kind of an all-time low for the last couple of years. No one was joining the military, and regardless of, like, what the military does, it still does provide a lot of great structure for people. Especially, I know a ton of people who, again, didn't have parents growing up in their lives, so they have no ideas of discipline, or they didn't have a father figure, and the military is an amazing thing for providing that, because you basically get a dad. His name is your drill instructor, and he yells at you constantly. But it builds discipline, and it builds, like, great character of, like, following a schedule and orders and whatnot. Oh, Chicago. That's dope. Cool. Yeah, and exactly. Nightmare says, yeah, I've hit rock bottom financially and faced struggles so I've never imagined. And so, yeah, benefits and money. 100%. They will pay you. And, yeah. Again, you get room and board. You get meals. You get a place to sleep. It's better than going homeless. So, like, you know, I say, like, you know, fuck your morals and ethics if the alternative is to be homeless. And, you know, I don't think we're the absolute. There are worse militaries out there. I mean, if you were telling me you were gonna go join the Russian military, then I'd have some questions, right? I'd be like, I don't know if you should join the Russian military right now. I like to be optimistic that we're doing the right thing at some point. I know we didn't in a lot of places, but we try. Yeah, father of 2, I needed to do something. Well, good for you, Nightmare. Dude, yes. 100% good for you. I completely support that decision, and I'm glad that you were able to study with us and get the ASVAB score you needed to get into the Navy. That's really cool. Yeah. Taxes support the military instead of healthcare and education. They do. I know. But it's that or they go to Amazon. So, I don't know. I'd rather them at least help someone like Nightmare to like support a family. I think that's okay. I agree, man, dude. The whole reason I've been streaming so much this quarter is because UCLA doesn't have money to hire me as a professor anymore. So believe me, I personally understand the hit of education getting defunded, but we can still do this. You can still do things to help people. All right, let's see what Sibley's got for me. Sib. Yeah. We had a military guy on our podcast once. I invite you to go watch it at some point if you want. Here, I'll show it to you. And he talks about like why he went and like how it helped him, and also the military isn't forever. You know, you do your whatever your 6 to 8 years you sign up for, and then you're a free man, and then you also have benefits. So here, this is a podcast I did with my really good friend Tony.
My way to
yeah, and he was in the Marines, and he talks a lot about like, you know, his journey. He did 2 tours in Afghanistan straight out of like high school almost. He went to college for a bit, and then ended up failing out of college because like things weren't working out. Joined the military, turned his life around, and now he's an audio engineer in Los Angeles, and he works on concerts and shows. And he has health insurance, and he has a stipend, and the military paid for him to go to college after to do audio school stuff. So it is 100% a viable path forward for improving your life sometimes. Yeah, being disabled, yeah, that sucks. I'm sorry. Well, not that one, but you can stay in, yes. All right, let's see. A circular conducting ring of radius r is connected by 2 exterior straight wires at ends of a diameter of that. The current eye splits in unequal portions as shown while passing through. What is B at the center of the ring? Ooh. Yeah, for sure. Yeah. Okay. Is this Bio Savar? I think we do Bio Savar for this. Yeah. You're good. I think I want to use the Bio Savar law for this. Let me just pull it up. It is, yes, but I would argue that the military is not as bad as being a whore on OnlyFans. Like, at least the military doesn't, like, post pictures of you that you can never be taken back and stuff. Unless you work at, like, Abu Ghraib or something. Okay, let me get... It's from this. Let me get this equation or something. Okay. Yeah, so this is where it comes from, Sib, right? So, DS, right? It's an integral. You think OnlyFans... Dude, I think OnlyFans is responsible for the collapse of our society. I have very strong opinions on OnlyFans, and yeah. It's an instant ban in my server. If you say that word, you're instantly banned. I will agree, Femvox, that they're both valid. They are both valid ways, yes. But I have such a strong, like, there are so many problems in our society that have been caused by OnlyFans. I think it's both, Mathematic Fanatic. It's a symptom and a cause, for sure. It had good intentions. Like anything, it started with good intentions. It was trying to give like adult workers like responsibility of, ownership over their content, enabling them to not get taken advantage of by like studios and blah 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 blah. And then it turned into its own little beast, and now it's a monster. Yeah, exactly. We all goon. Maybe we shouldn't. Maybe that's the problem. Maybe that's why our birth rates are declining so fast. Yes, they want to curl your fingers. Thanks for the heart, Wolf.
Bing bong.
They want us to curl our fingers and extend to the midpoint? What, the midpoint? No. Okay. So what happens here, right, is you're going to, if you ever want to figure out the magnetic field at a certain position, yeah, you do DS. So in this case, this is DS. This is R. So DS cross R. Oh wait, I think no. R points. Does R point from the segment? Yeah. So sorry, if this is DS and then let's look at this case. Let's just look here for instance. I think you're right too, but let's show exactly how it is. So at this instant, right, this is DS. I believe this is R. This is like R hat. So DS cross R, yes, would put magnetic field into the page. Which if you do this rule, like curling your hands around, should also do it. Okay, great. That's fine. Yes, from the wire to the point, yes. And then the cool thing about it being a circle, right, is that as I go around, DS is always tangent to R hat. Right? Or it's supposed to be tangent. I mean, I could try to make it tangent. There you go. Nobody knows. It's definitely the right-hand rule. Yeah, okay. So, yeah, so let's try to integrate. So, so then DS. Okay, so now you have to integrate DS. And that is an arc length, okay? So, I can get rid of the cross R hat because I know this will always point... Because if DS is pointing this way, R hat's pointing this way, S cross R always points into the page. So we can get rid of the cross product. And now I just know this is integral of DS over R squared, and then this is in the negative Z hat direction. Yeah. So looking at if the circle is going down or up to see the direction of the tangent vector. Yeah, so here, right, now the tangent, well, DS always points in the direction of the current, right? So here the current's pointing this way. R hat's pointing this way, right? So this is the same thing as X hat, and then this would be Y hat. Right? Oh, interesting. Yeah, so this component is going to point into the page. This component is going to point out of the page, right? Because X hat cross Y hat is positive Z hat. Cool, right? And in this case, you have X hat cross negative Y hat, and that equals negative Z hat. Oh, thanks for the gifts, Wolves.
Bing bong.
Yeah. Is it, wait, I don't know about the quaternions. Okay. So we have mu naught I over 4 pi, and then we'll figure out what the I is based on, like, whichever loop I'm in. Yes, you do. Yeah. When it's not perpendicular, you just throw a sine theta in there, for sure. And then, I mean, sometimes with BS of R, it, like, cancels out, so you only want, like, one component. Okay, cool. So then DS is the same thing as, so DS is equal to R d theta, integrated, in this case, from, we're going to integrate from, whatever, 0 to pi. effectively, right? And so, and then you don't even really need to do this integral, right? Because ds is just talking about the circumference of half a circle, which is just going to be pi r, right? Yes, the cross product is gone because ds always points in the theta hat direction, and then r hat. So theta hat cross r hat is always equal to z hat or negative z hat. It just depends which one it is. So this is for like the top. Capital R? Yeah, technically you're right. Yeah. And then here, this is for the bottom. This one's positive. Cool, so then one of the R's is going to cancel, yeah? So then, this is going to be mu naught. Let me know, Sib, if I'm skipping too many steps. I'm happy to... This is I top. And then this is going to be, pi, yeah, big R over big R squared. And this is going to be the negative z hat direction. And then this is going to be mu naught I bottom. Where are these questions from? I don't know. I think Sib is like self-studying some physics. Good. Okay. Why is it no, you're totally good. Okay. So that comes from this, Sib, right? So R hat has a magnitude of 1, right? Anything that's a hat is a unit vector. So this does not contribute anything in terms of like the number. The number does not change. This only tells me the direction. So I already know that since theta hat cross, since this is like some magnitude ds theta hat. Whoa, totally different look on Twitch. Yeah. Again, I tell people go check out Twitch. The horizontal's easier, but YouTube's just better for exposure. Since ds points in the theta hat direction, r hat points in the r hat direction, I can get rid of this whole thing and just say, oh, it's just z hat direction. But ds still has a value, right? In reality, like, ds vector is equal to ds theta hat. This is still a number. This is just a unit vector, so it's a direction. Yeah, you can. Yeah, submit questions. And so that's where that happens, Sib. That's why it becomes ds over r squared. And then what you figure out is that integral of ds is just the arc length of half a circle, which is just half the circumference. Actualofficehours.com, that website down there. Why is my moving text not working? What the fuck? One sec. Should be working. No, not that one. Yeah. This one, why is it not animated? Okay. I don't know why it's not working. Alright. Okay. And then this is in the positive z hat direction. So, summing them together. Yes, because r is constant. Exactly. Yeah, it won't always be constant, but in the case of the circles, it is. So I get mu naught over 4 pi, and then there's going to be an r, right? And then this is going to be negative I top plus I bottom. I think so. Oh wait, there's another pi r. Sorry, the pi cancels out. There's no more pi's. Happy Circle Day! Yes, Happy Circle Day. we literally are dealing with circles right now. Isn't that too funny? I love rotating. I do too. Okay, so mu naught over. Did they give us a radius here? Oh, they just don't tell us. Okay, right, fine. Mu naught over 4r, And then I top, so it's negative 0.65. You bottom? I had 2. God damn it. Alright, so then that's equal to negative 0.3 mu naught over 4r z hat. And that should be it. I think so. Yeah. Which what is that? That's 3 over 40, right? So negative 3 mu naught. I do know about chem. I definitely do. I definitely know. 40r z hat. Yeah. Yes. Yeah, no, Wolf, you can watch it on Twitch. It's much better to watch on Twitch, Wolf. So if you want to watch it on Twitch, we broadcast everywhere. Go to the website, actualofficehours.com, and just say watch live on Twitch here. Twitch is horizontal. But a lot of people find us on their phones, which is why we stream vertical on Twitch. On TikTok. Yeah, you're very welcome, Sib. Good question, by the way. I like that. JC says, I wonder what a human's average rotation over a lifetime is. Like, over my entire lifetime, will my angular displacement be clockwise or county? I mean, it should be. I guess it depends if you're right-handed or left-handed, right? Yes, you're more than welcome. Yeah, Wolf. Yeah, go find us. Make sure, yeah, like, subscribe, whatever on Twitch too, so you get notifications. Cool, good question, Sib. I like that one. That was cool. Done for Sib. I think, yeah, well, this sounds like a science experiment, JC. Maybe we could do something like in a week. Like have an accelerometer attached to you or something, right? Entropy? Entropy is chaos. Entropy is, like, organization or whatever. Now, here's the cool thing. We can see if this would reduce to what we wanted to. If, let's say, for instance, I-top was, like... Let's say that they were both 1/2 I, right? And that they were not running in the same direction. Then this would have become just, I. And I think mu naught over 4r is for just a, let me see, magnetic field current of loop r. I think it's just mu naught over 4r. Mu naught I over 2r. Ooh, why is it over 2? Fuck. Oh, and they still have a pi in there too. Do we minute? No, I could have sworn there's no pi. What? Did we mess up somewhere? Oh, okay. Sorry, if we went the full thing around, yeah, no, I would have gotten 2 pi r up here. And then that would have been mu naught over 2r. Okay, cool, great. Alright, we're fine. Alright, I just needed to sanity check myself for a second. Okay, we're fine. Yeah. You can't just add the currents. You also have it also has to be twice the distance. BSFR just is used more practically to calculate B field for situations that are not so symmetric, right? Yeah. Exactly. Yes. No, you have exactly the right intuition there, Sib. Yeah, we use BSFR with like tricky situations that yeah, Gauss's law doesn't work or there isn't like nice symmetry for Ampere's law. I think the classic way it gets used is it this? Yeah, this question always gets asked. Yeah, this. So yeah, finding like the B field up at a point P that's like above the loop. And this is where I think someone was asking if it's not on axis, what do you have to do? This is where you need the sine theta in there. Yeah, this is a classic question that comes up as well, at least in E&M. Okay. Let me see what else we got. Find the non. Okay. Yeah, you're very welcome, Sib. Oh, let me give you a coin, Sib. By the way, you get a coin for that. Okay. Find non-VE integrals. Yeah, you're right, JC, that R is perpendicular to DS, but then it points in the, it doesn't just point in the Z hat direction, right? It has components in the X and Y direction, but then the X, Y directions cancel out. And that's why you need the sine theta to pull out, or maybe it's cosine theta to pull out the Z hat. It's a P and C question. Well, what's P and C mean? Oh, find the non-negative integrals of x plus y plus z plus t is equal to... Is that 2g? I don't know what P and C means. Partitions of 23. Wait, is this supposed to be a 23? Well, I don't want to write so many things out. I got 11 other people waiting for me to answer their questions. It's not difficult. Okay. Oh, permutations and combinations. Oh, okay. Okay, so non-negative. Use the multinomial theorem. You guys are teaching me stuff. I've never seen this before. And then... Yeah, maybe, JC. I'm not exactly sure. X plus Y plus Z... Is this plus T? Is equal to what? What is this? Is this... I'm assuming this is a 2. Is this 2G? You think it's a 29? Oh, I think it's a 29. Okay. How do you draw on the screen? I have an app that I use. Yeah, how many solutions are there? One sec. We've been on for more than 3 hours. Let me clear this. Okay. Okay. Group world. Group world is what I use. Wanted. X minus 1, Y minus 2, Z minus 3. Oh, interesting, because it has to be greater than it. Okay. I use stars and bars. Okay. And they have to be integers then? Why do they have to be integers? And I think it's to 29, right? Not 23? Oh, actually, no. I see what you did. But why the 23, not the 29? Is that because 1 plus 2 plus 3 is equal to 6? And then this has to equal 23? I can definitely do... Yes. Grade 10 math, 100%. You subtracted 6 from both sides. Okay, I get it. Because now you're just... I see how this is also kind of encoding what the requirements are, right? But wait, what am I supposed to do from here? What is next? Each of them are exactly onch. I agree with that. Each of them are now just greater than or equal to 0. I agree with that. Yeah, that's cool. Nah, are they? Well, greater. Okay. It's actually asking the number of ways of non-negative integral solution for that equation. Okay. Now I don't know exactly what I'm supposed to do here. JC got 2600. Here, I'm gonna throw this in my Discord. JC, you want to can you post your solutions for it for me? Just because I don't think I'm gonna get this anytime soon. It'll be 26. Choose 3. Midaruno. Okay. Yeah, I don't know the multinomial theorem. And I only got 35 minutes left, so I don't think I'm going to learn it real quick. But well, it's not the beggar's method, but isn't it something with like the carrots or something? Yeah, okay. Here, I'm putting this in my Discord. It's right here. If y'all wonderful people want to join my Discord and discuss it, that'd be really cool. And maybe I'll learn something from it. But otherwise, cool. Alright, let me go next one real quick. 23 plus 3, choose 3. Let me see Sebas. Nice. Ooh, I like this, Sebastian. Happy poop for 10 joules. Thank you, Ely. I don't know what I'm supposed to do with happy poop, but cool. Thank you. Appreciate that. Okay. A balloon raises at a rate of 2 meters per second from a point on the ground 30 meters from an observer. Find the rate of change of the angle of elevation of the balloon and the observer. Oh, cool. This is related rates with angles. Yeah, this is fine. Okay, so... Sorry, my bad. Yeah, Discord was up. My bad. Yeah, thank you. Alright, 30 meters from the observer. Find the rate of change of the angle of elevation. Angle of elevation is usually theta. Or, yeah. So that's this. When the balloon is 20 meters from the ground. Cool. That's actually really nice. It's a fun one. And so this is 25, right? But then we say it's rising at a meter of 2 meters per second. So we say that dy dt is equal to 2. So this is the rate I'm given, okay? And then the rate I'm looking for is equal to the change in the elevation. So that's d theta dt, okay? This is all you have to do with related rates questions. You now need to just come up with an equation that relates these two rates. That's why it's called related rates. And so how do I relate y to theta? What's up, Aben? I can do that using tangent, right? I know that the tangent of theta is equal to opposite, which that's going to be y, over the adjacent, which is 30. Oh, thanks, Joseph. I'm gonna check. I'll check that right after this one. But so here you go. So Joseph has posted a solution here. Midaruno, if you want to see how he did it. Sorry, sorry, it's over X. Sorry, sorry. I was getting distracted, sorry. Well, X is always 30, Sebastian, right? Like, no matter how far this thing goes up, right? The X is always equal to 30. Does that make sense? Like, also, you don't want to start introducing new variables that you don't need. Yo, Dr. G, did you train your personality today? I didn't go to the gym today. Today's my off day. Sunday's my rest day. Okay, so once you have this, right? You now want to... Well, actually, so we want to get theta by itself. So theta is equal to the arctangent of y over 30. And now I need to take the derivative of both sides, right? So I'm going to do d dt What's up, Lineatrix? And then I'm gonna do DDT of this. So much math and physics. Yeah, there's a lot of math and physics. Well, you know, the world works in strange ways, Lineatrix. Sometimes, you know, you just stumble upon things. What's the derivative of arctangent? Is that 1 over 1 plus x squared? Oh, you want me to differentiate before the inverse trig? Smart. Yeah, let's do that ahead of time, because, yeah, I don't want to fucking take the derivative of arctangent. Yeah, exactly. Yeah, I know who you are. Okay. Yeah, let's do DDT first. Max, you are right, though. Yeah, but here, let's just do this. This will make life simple, right? So, so derivative of tangent is secant squared. So I get secant squared theta, but key thing here, I don't know how theta depends on t. So it's secant squared theta times d theta dt. And then this is just equal to 1 over 30 dy dt. Right? Cool. Nice. And then we know what dy dt is. Dy dt is equal to 2, right? So then I get that d theta dt is equal to 1 over secant squared. 1 over secant squared is cosine, because secant squared is 1 over cosine squared. So I get cosine squared theta times 2 over 30. Right? So if I move this over, 1 over secant squared is cosine squared. And then dy dt, this is equal to 2. Alright, but now I need to find the cosine of theta. Which this is fun, because I know this is at 25. I know this is at 30. So then you can figure out what... So, right, cosine of theta is adjacent over hypotenuse. I need to figure out what the hypotenuse is. We're going to get it right here. Yeah. So you know that this is happening when y is equal to 25. X is equal to 30. So now I need this in order to do cosine of theta. So this is going to be the square root of 30 squared plus 25 squared. This probably would have came out if we did the derivative of arctangent anyways. Yes, exactly, Lineatrix, right? So d theta dt is equal to the adjacent 30 over the hypotenuse, which is the square root of 30 squared plus 25 squared. Squared. Times 3 over 30, right? Is it 5 squared is 61? Is that really what it's going to be? That's so ugly. Okay. Well, at this point, I'm just going to use the calculator. Because there's no need for pain. Alright, 30 divided by the square root of 30 squared plus 25 squared. Okay. And then squared. Oh, your teacher had it in radical form? Really? Okay, fine. Ooh, okay, fine. What is that? That's 30 squared over... So squaring a square root gets rid of it, so you get 30 squared plus 25 squared. I guess this isn't too bad. Okay, plus times 2 over 30. So one of these 30s cancels. Wait, why? Sorry, why are you guys getting radical form, by the way? Sorry, what? So I don't think it ends up in radical form. I think it's just 60 over 900 plus, was that 625? Oh, awesome. Yeah, I'm glad. Yeah, welcome, dude. Welcome. Yeah, Twitch is honestly not the best at giving us exposure and, like, discovery, which is why, again, I stream on vertical to all the other channels as well. Okay, so 16 over 1525, right? Twits. It's kind of a fun name. Okay. So, whatever. That gets me 12 over 305. I don't think that can be divided anymore. No? Yeah. And then this is, yeah, radians per second. Check my math, but I think we're good. Cool? Alright, nice. Great. What does radians per second measure? It's like degrees. It's measuring like the change in the angle. Nice. Yeah, it's the same thing as like degrees per second, but it's, you know, it's nicer. It's more math friendly. Like, so 2 pi radians per second would be 1 revolution per second, because that'd be 360 degrees in a second. Drink water. Thank you, JC. I do. What is this song? It sounds kind of chill. This is all generated by AI, this music, because otherwise my videos get bopped for like copyright. So I just had AI generate a bunch of like synthwave stuff. Yeah, nice. Okay, this was Sebastian's. All right, what, we got 24 minutes left. I think we can get through a couple. Descendant fonts. What is this question? Every finite group of prime order is cyclic. What is? Or are you just saying? Are you commenting on how today is like Circles Day? Oh yeah, I could release it, but then I worry that like if I release the background music, that then YouTube would say that it's copyrighted or something. How did 3 hours turn into 30 minutes? It shouldn't say that. Wait, 3 hours? Where is it saying 30 or 3 hours? Every prime has a primitive... Well, I'm confused what the question is. Are you just trying to prove this? Okay, I'm gonna submit this to our Discord anyways, and maybe one of the math gods can like explain like what's going on here. Let me see what we got for the next one coming up. Yeah, see, now you guys are speaking different languages. I'm like, yo, what's going on? All right, let's see. Odin's got a question coming up. This looks probably doable. A 360 nanometer. Where do you submit questions? There you go. The indices of refraction of the oil in the water are 1.5, 1.33. When the surface of the oil is illuminated from above at normal incidence with white light, what are the 2 wavelengths in air of light between that are most strongly reflected? Okay, so that's where you have like positive interference, right? I'm a physics professor, but I do a lot of math as well. Okay, so wait. Sorry. So let's get like the oil and the water. Two pixel resolution. Yeah, this is struggle. Odin, dude, what'd you give me, dude? I did. I taught at UCLA in the spring and the summer this year. I may teach again next year. What's your favorite video game? The Finals. My favorite video game. I think it's a great game. I have started liking Battlefield 6 recently. Okay, so this is 360 nanometers. And wait, so this is n is equal to 1.5. This is n is equal to 1.33. And then this is air. This is equal to 1, right? And then you have light coming in. Right? And then, like, some of it reflects off. And then, let me think. I want to say if it goes into a lower index of refraction, it bounces, right? Yeah, I heard that. Well, good for Jeff Bezos. I think this is what happens. It's like this is like the thin. Do I care about the 1.33? Because then what happens is this has like some wavelength, right? And then it's gonna come in and have like a different wavelength. It's gonna bounce off, and then I need that to line up with this one, right? And I need it to shift over by a whole wavelength, right? Not half a wavelength would be negative interference, right? Okay. Let me figure out where this is from. Yeah, this is what happens for sure. Okay. Yeah. 2NT. 2NT equals M, right. And I think there's just one phase shift. Oh, here we go. Ooh, yeah. Right, okay. But see, I don't think we need to do it with the angles either. Yeah, here we go. This is cool. But then what's the... Yeah, this is cool. Okay. Yeah, let me explain how this works.
Nice.
I am beyond confused. Yeah, no, here's what happens. Okay. So when when light is traveling from a lower index of refraction to a higher index of refraction, it is going to bounce off. Part of it's going to bounce off, part of it's going to go in. And the amount that bounces off shifts the wavelength by 180 degrees, okay? So if, for instance, your wave looked like this coming in, then your wave that bounces out would look like this. It's shifted by 180 degrees. I think I kind of regret studying in a homeworkless school because it sounds like asking Dr. Gold for a homework question sounds pretty fun. Thanks, dude. Does that make sense? Like, fuck, I need... Because, this right here would be in phase. This would be 0 degree reflection. This is 180 degrees of reflection. Okay? Alright. And then, when something from a higher index of refraction hits something of a lower index of refraction, it bounces off, but there's no, shift. There is no phase change. But it does travel an extra distance. Right. And the extra distance it travels, that I have to work out with, like, N and C and lambda, right? How does that work? N equals C over V. Yeah, okay, that's what I wanted. Okay, so... Ooh, I don't, but I have friends that do, James Wright. Yeah. If you want to go to that website and then click on the schedule, there are some other math streamers that definitely deal with, like, topology and stuff. Okay, N is equal to C over V. Right? N is equal to C over V. And then... Man, it's the distance, right? I remember how this works. So I need the extra distance it travels needs to be half a wavelength in order for it to line up with whatever happens. Okay. You know some topology? Oh, that's cool. So wait, it can be half a wavelength or 3/2 of a wavelength. Yeah. Yeah, okay, okay. In order for it to line up with this one. Okay. So 2D needs to equal 2m plus 1 over 2 times lambda. I think that's how that works. Yeah? And then, does the... I wonder if... Does the n matter, though? Because you are going to... the velocity of light changes, right? But v is equal to... lambda f, right? So c over lambda f... And I think the frequency doesn't change, but the lambda does. Oh, but then it exits again. Okay. Mathematic Fanatic, teach me some topology, please. Mathematic Fanatic, he's saying teach me some topology. Okay. So, okay, and it's all in nanometers, which is actually kind of nice. So, 2 times 360 needs to equal 2n plus 1 all over 2. And then these are lambdas between like 400 and 800. Okay, cool. Wait, but the effective distance it travels. Okay. This is different, though. Yeah, I think you have to do n times d. And I think that comes from this, right? So if n is equal to c over v... So v is equal to c over n. So then vt is equal to ct over n. No. Oh, I see. Yeah, but here's the issue. The light will slow down in the different index of refraction, right? So yeah, there's a thing called there's optical distance. which is assuming that everything has the same index of refraction. And that's equal to n times the physical distance. So optical distance is like constant wavelength. Oh, okay. So I think I have to put n in here. I have to do 2 times 1.5. Yeah, okay. Okay. And then just times lambda. Okay. So then I think we just like we just plug in some numbers, see what happens, right? So 1.5 times 360 is 540 times 2 is 1080. Nice. Wow, look at that. 1080 is equal to like just odd numbers of 1/2 plus lambda. So let's see what like 1/2 lambda would be. Well, that's way too much then. Right? That's already way up there. Okay. But what if it was 3/2? I think that would work then. Right? Oh yeah, 3/2 of is just 720 because it's literally just this. Nice. Okay. Here, okay. So here, this is, let me just say like 1/2, 3/2, 5/2, ... Okay. And so yeah, 1080 is equal to 3/2 lambda. Lambda is equal to 720 millimeters. Nice, Faison. And then 1080 is equal to 5/2 lambda. That gives me lambda is equal to, well, 2/5 of that. That's nothing nice. What's that? $432. Cool. Yeah, thanks, Faison. I appreciate that. And then, sorry, this is all nanometers, not millimeters. Okay, nice. And those two are within, yeah, 400, 800. Okay, cool. Great. Awesome. All right, nice. Good question, Odin. All right. Let's put Odin's in. I think Odin, what's your name again? It's like Funny Sneaker? Or Funny Snake? Funny Snake. Like Funny Sneaker. Why does the phase flip when reflecting in higher N but not when in lower N? That's a good question. Like, why? Oh, I actually don't know why. I think it has to do with something with Snell's law, probably. I just know that's a rule that happens. It's also like, so if you've ever seen, if you have a wave, like let's say a rope, and you have it like tied to a fixed point here, the things that reflect back are always 180 degrees out of phase. If you allow this thing to like move up and down, then the reflected waves don't move 180 degrees. It's like a fixed boundary point, I guess is what we say. Yeah. Kind of. Yeah, I think that's where it comes from. I'm sure ChatGPT has a let's just Google like why. Might as well read it, yeah. Okay, so if you want to know the rule, JC, it comes from boundary conditions of electromagnetic waves. Yeah, it has to do with the electric field and the magnetic field. It's a little bit more complicated. Yeah, check it out. Yeah, it has to do something with amplitude reflection coefficient of the electric field. I like to think of it as like, yeah, higher index of refraction is stiffer, which is kind of my idea of like, if you had a fixed thing that you're like bouncing waves into, they always like bounce back 180 degrees out. Yes, and Chad even says this. It says like a pulse on a rope fixed to a wall, and when it's softer, it reflects upright. Yeah, like a pulse reflecting off a free end. Yeah. Yeah, that's cool. All right, let's see what the next question is. It's from Inder. What do you got from Inder? Rolle's theorem. Ooh, I do like this one. This is cool. Prove that the equation x cubed plus x minus 1 has exactly one real root. Okay. So Rolle's theorem says... So we have to... So first, like, check. We have to check a couple things. First, like, is it continuous? And that's yes, right? Because this is just a simple polynomial. Okay. And then what we need to do, in order for Rolle's theorem to work out, I need to show that there's a point up here and a point down here. Or no, wait. Yeah. Rolle's theorem, does Rolle's theorem say there's no, Rolle's theorem that says that there has to be at least one real root, right? How do you show that there's exactly just one? Let me remember Rolle's theorem, sorry. I know Rolle's theorem can show that there has to be at least one. Oh, Rolle's has to do with the derivative. Oh, okay. Wait. How does Rolle's theorem help you have just one root? Prove that the maximum is less than 0. Yeah, here's what Rolle's theorem says. Rolle's theorem says that the derivative of the function has to be equal to the average between 2 points. Right? Okay. Well, okay, so let's look at like f prime of x. That would be equal to 3x squared plus 1. This is always positive, right? So always increasing. Okay, and if a function is always increasing, you just have to show at some point it's below, which it is, right, at x equals 0. So here, this is like 0, negative 1. And then, I don't know, let's say like, this is like 2, it's 8, 2, 9, right? So instantly, because I know it's always positive and it's always increasing, that it had to have at least one root. Oh, here's why I can't have 2 roots. Okay. In order to have 2 roots, the function must have f prime of x equal to 0, right? It had to have a turning point. Oh, okay. But f prime of x equals 3x squared plus 1, which is always greater than 0, so not possible. Okay, so yeah, so it can only have one root then. Right, it never has a maximum, if anything. Right? That makes sense? Yeah, cool, Ender.
Good job.
That's kind of that's a weird proof that they want. But yeah, that is true. Yeah, that's cool. Nice, good job, Ender. Cool, Ender. I'm gonna put that in our Discord for you. So if you want to see it. Kind of a cool one, though. Oh, are we out of time? Shit, we got 27 seconds left. Uh-oh. We've just got seconds left. Yeah, unfortunately, I have to go teach another student today. This was Ender. Is Penn Center live? He will be live soon. Should be. But nice. There you go, Ender. Solution is here in the Discord for you. Is Penn Center... Yeah, let's go check if Penn Center's live yet. Penn Center. He's doing a data science class today. Penn Center. Is he live yet? No? Is he live yet? Oh, he says check me out, though. That's nice. Thank you, Penn. Oh, really? Joining the Discord doesn't work? That's so... Wait, what country are you in? Sometimes if you're in a different country, it's being weird. Canada... It should work. So, like, literally if I go to... If I go to here and I say join our Discord, it should pop up. Yeah, this is the invite. And then it says you can join. That's so weird. I gotta think of another way for that to work. Yeah, try it on a different browser. Try it on like your desktop or something. It should work. But some people have reported they have problems with it. Yeah, exactly, Phazin. I agree with that. Is a less general version of the mean value theorem. Roll says there's at least point. Oh, that's what I was thinking of. Can you solve 2 + 2 is equal to 5? What did Sigma Sauce ask me? This one's kind of tricky. I do have to go like kind of now. Let me see if there's something like really easy I could solve. Ooh, no, not that. Something with Kosh. Oh, you guys are asking all sorts of interesting ones. Man, this one I could have done too, actually. Fuck. Okay. And Phasey, dude, with this one. What is this? Phasey. How am I gonna do 4 over 3 + 5 sine theta, dude? What? It works on desktop? Cool. Yeah, mobile's just being weird, I think. Okay, great. Okay. I do have to go. Because I have another person I have to teach. I wish Penn Center was on. He said he was gonna be on it this time. But I guess he's not. Yeah, you're very welcome. Okay. Let's close out the stream. Alright, thank you everyone for coming to Actual Education Office Hours today, our Sunday stream. If you found this helpful, please make sure like, subscribe, share, all that good stuff. It helps the algorithm tell other people who we are and gets our name out. If I was not able to get to your question today because we ran out of time, do not worry. That all your questions are going to get posted into our Discord, and there other people may work on them, or if I have time in my free time, I will also just do them as well, or on another stream. But goodbye, Jake Hull. Yeah, thank you, Faizan. So yeah, be sure to join our Discord clicking here. I think it's better if you do it on desktop. I'm not the only person that does this, so if you want to know other awesome streamers, click on the streaming schedule here, and you will see when our next stream is, which will be tomorrow at the same time, but in tomorrow. And then also, we have some other awesome people who have joined streaming educational content on Twitch. So Penn Center is doing a data science course on his Twitch right around now. Zach will be doing coding development tomorrow morning. And then Joseph, newest addition to our stream, streaming schedule. JC is doing a stream Tuesday morning for you early birds or anyone else in like the UK, India. Like he streams around that time because he's in the UK. Okay, so let's go raid Penn. Awesome. I'm glad Penn is here. Okay, cool. So yeah, let me go to my stream manager. And again, thank you everyone for like your questions. I really appreciate them. Come on by tomorrow and we'll make sure you get some help. And other people just learn. I mean, I love everyone in the comments section and the chats just helping me learn as well. All right, where is Penn Center? Cool, Penn Center starting soon. Okay, we're gonna go raid him. All right, that being said, thank you everybody. Enjoy the rest of your weekend. We will see you tomorrow. Peace. Oh, Penn, where'd you go? You were literally just here. Oh, okay. All right.